Hello PLP Geometry and welcome to video number 5 from Unit 3. Again, we're still talking about more with triangles, and today we're going to talk about some algebra-ish type concept when we talk about inequalities and triangles. Alright, so Unit 3, again, more with triangles. And this is number 5. And again, we're going to talk about some inequalities. Inequalities in triangles. And again, if you remember from algebra class or even middle school, inequalities we're talking about are like less than, greater than, right? All that fun stuff. So let's talk about how these can be incorporated with triangles. So we're going to talk about two main ideas in this video. So the first main idea is called the triangle inequality theorem. The triangle inequality theorem. And the triangle inequality theorem says that the sum of the lengths, of the two shorter sides, the sum of the lengths of the two shorter sides of a triangle is greater than the length of the third side. The sum of the lengths of the two shorter sides of a triangle is greater than the length of the third side. So I'm going to draw two triangles for you right down here. So the first one, we'll actually draw a triangle like so. And we'll call this length 33, and this length 37, and this length 66. So if we check the triangle inequality theorem, if we take 33 and 37 and add them together because they're the two shorter sides, so 33 plus 37, that will equal 70. And 70 is greater than the third side, 66. So this checks out. This is why this triangle exists. Now let's look at this over here. So I purposely did not close this triangle. So we're going to let this side be 19, this side be 18, and this side be 40. So now if we add up the two smaller sides, 18 and 19, we get 37. And this is smaller than the third side, 40. So now notice, because there is this inequality relationship not followed, we have this gap right here, right? The two sides cannot close that gap and make a triangle. All right, so again, this is called the triangle inequality theorem. Okay, so over here again, this is not a triangle, not a triangle. Okay, let's talk about the second main idea. Now, this main idea is going to be very helpful when we get into right triangles, which is where we're going to go next in Unit 4. We're going to continue our right triangle talk, or triangle talk, and we'll use some similarity and do some right triangles, but that is for a later conversation. So here is our next idea. In a triangle, the largest angle lies opposite the longest side. In a triangle, the largest angle lies opposite the longest side. So let's draw a triangle here. So we're going to call this triangle MNP. So M is at top, N is over here, and P is on the left. And we have PM is 8, we have MN is 23, and we have PN is 26. So what we're going to do in these problems is we're going to order our sides and angles from least to greatest. Now, if you look at the picture, we know the side lengths, right? If I was to put these in least to greatest, I know that 8 is less than 23 is less than 26, right? That was given to me. That's not that hard, right? Now, if I use the 2 letters to name each length, so 8 is representing MP. So that means that MP is less than, 23 is representing MN is less than, and 26 is representing NP. And again, that's not that hard because we just follow the letters that they give us. But now, notice we have no information about the angle measures in this triangle. However, because I know the order of the sides, I can put the angles in order from least to greatest. Because 8 is the shortest side, I know the angle opposite of this 8 is going to be the smallest angle. 8 is opposite of angle N. Notice how angle N, if I put a little arc here, notice how angle N's arc opens up towards that 8. That means that the side of 8 and angle N are opposite of each other. So the measure of angle N will be the smallest. And if you kind of look, it looks like it's the most acute angle in the picture. So then we have MN as the next biggest side. Well, that's going to be angle P. Angle P opens up to MN. So the measure of angle P will be the middle angle of the triangle. And then lastly, because side NP is the biggest, that would mean that angle M is going to be the largest angle. And this is what we really want to care about. We want to show that given the side lengths, we can put the angles in order from least to greatest. Now this also works backwards if we work with the angle measures and look for the side lengths. So I'm going to draw this picture here. All right, so this is K, L, M. And say they give us that angle M is 62 degrees and angle L is 50 degrees. And we want to find what is the order of the sides from least to greatest. Again, that's a 50. Sorry for not being so clear. 50 degrees. So the first thing that we must do in a problem like this is we have to find the third side, right? We need to find K first. So let's do that. So let's find the measure of angle K. Find the measure of angle K. To do that, let's take the two angles we have, 50 and 62, and add them together. That's 112. And let's subtract that from 180 to get 68. Now I know that the measure of angle K is 68 degrees, and I can put it right here. So now that I have my three angle measures in order, or known, I can put them in order, and then I can put the side lengths in order. So from least to greatest, so 50 degrees is less than 62 degrees is less than 68 degrees. Angle letters now. That means that the measure of angle L is less than the measure of angle M is less than the measure of angle K. Again, just replacing the angle measure with the letters. So now I need to identify these sides that are opposite of these angles. Again, my picture is not very telling. All the sides look the same. But if I start with angle L, this 50-degree angle right here opens up to KM. So KM will be my shortest length. Angle M opens up towards KL. KL is my next shortest side, or my middle side. And then K is opposite of LM. And there would be the lengths of my three sides of this triangle in order from least to greatest. So when you're doing your delta math, just make sure you pay attention to the wording, right? For the triangle inequality theorem, sometimes it says does create a triangle, sometimes it says does not. And then for this one, again, sometimes it's least to greatest or greatest to least. So just be very careful with the wording. All right, thanks for watching. We'll see you in class.